continuing on with our lecture on skin, we're starting with the dermis for part 2. So in your outline, B letter is the dermis. And I want to, again, just reinforce that the dermis has 2 layers to it. The papillary layer is the uppermost layer, about 20% of the dermis is areolar connective tissue. And this is found in the papillary layer. And then the second layer, which is the thicker 80% of your dermis, is the reticular layer, which is your dense irregular connective tissue. So again, the papillary layer is areolar and the reticular layer is dense irregular. Remember that the dense irregular connective tissue is the collagen fibers running in different directions that help to add that resistance and strength to skin. Your skin also has elastic tissues in it, but the collagen is what really gives the skin its bulk and its strength and resiliency. So let's look at the next slide here. So which of the following allows the skin to stretch and recoil? This should be pretty simple. I just mentioned it. It's collagen, letter B. Which of the following would be considered to be the cutaneous layer? So remember, the cutaneous layer is the same thing as cutaneous membrane. If you don't like layer, you can change that to cutaneous membrane. And your answer should be letter B again. Remember, skin is just the epidermis and dermis, that the hypodermis is not part of skin. So letter B. All right, so we really are not going to talk about the dermis a lot, as you can see. We're going to move on to the accessory structures. Just because I'm seeing in the outline the hypodermis, let's just go pay some attention to the hypodermis. The hypodermis is going to have a lot of adipose. So adipocytes, right, are the cells of adipose tissue, which is fat. And this is where we're going to store a lot of our excess energy that we take in form of calories. It's going to pad our body. Under the skin, it's mostly for padding, protection, thermoregulation, and energy storage, obviously. So the distribution of this kind of fat will change over your lifetime. The adipose you see in children, they have very sort of round, chubby cheeks, round faces. And then if you think of the face of a grandmother or grandfather, the fat there is gone. So they no longer have a nice round face, but the adipose tissue does kind of go away in those areas. You can also find fat leaving the hands and underneath the skin. So there is a distribution change, and also obviously there's a distribution of subcutaneous fat that's different males versus females. And then also your body type. Some people store excess adipose in the hips and around the abdomen, whereas others might carry it in their extremities or evenly throughout their body. All right, so let's talk about the hair. Accessory structures beginning with hair. So hair is found all over your body except for the palms, the soles, the nipples, and external reproductive organs. Your hair is formed from epidermal tissue, but is located in the dermis of skin. So let's take a look at that. We see here a really pretty scanning electron micrograph of hair coming out of the skin. And so we can see how the very, very up close stratum corneum appears and how the top, these really flat cells just are ready to come off your skin. We can also see that's very similar to what a hair is. Your hair is a series of flattened cells that are dead, also filled with keratin, that are arranged in a cylinder, and they exit your scalp. So, or anywhere in the body where you have hair. So because these are so similar, right, they are formed in the same fashion. So let's take a look at what this sentence means. The hair follicle is the entire structure that makes the hair. So what you're looking at is a hair follicle. The purple, right, these cells here, this represents the epidermis. So the epidermal cells that are alive, they are in purple. The stratum corneum is the kind of other color here. So the living cells are going to dive down and they're going to create the hair follicle. So you see how the purple cells come down, they're going to make the hair follicle, and then they also create a gland that's associated with your hairs called the sebaceous gland. So the hair itself is formed in much the same way that your skin is, your epidermis is formed. It begins with the stratum basal. The new cells push the older cells up towards the top, except inside a hair follicle, they will be arranged in a cylinder, which is your hair. So let's take a look at the hair follicle. The entire structure that generates your hair is the follicle. The follicle will always have a bulb at the end. So the bulb of your hair is the rounded end. So the entire hair follicle bulb is going to be this round end to your hair follicle. Inside the bulb, there is going to be a papilla. Okay, so we've seen that word before. It actually, we'll see it again several times in the semester. It means little bump. Oops, sorry about that. It means a little bump. And we use that word to describe these upward projections of the dermis, right? This area is a dermal papilla. This area was a dermal papilla. Now we have a hair papilla, and the hair papilla is a space of connective tissue that works its way into the bulb of every hair follicle, and it's to supply the blood to the regenerating hair. So your hair grows from the bottom of the follicle, okay? And that's what the papilla is for. So the papilla, since it's connective tissue, is always going to show up a little bit lighter in a histology image. So now let's look at the different other terms you have here. So the root of the hair is where the hair is formed from the bulb to where it is organized. So notice here that the root, the hair root, is pointed out in the lower 2/3 of the hair follicle. The upper 1/3, we can start calling that hair the shaft, which is also what you call the hair that exits the scalp or the skin. So the shaft is organized and exits the skin, whereas the root is not yet quite organized. And so there is a boundary where that happens. But we can just simply say 2/3 of the hair follicle deep is the root, and the upper third is the shaft. All right, so let's look at the hair itself. We're going to move to a picture here. So the hair itself is has 3 different layers to it, which is under hair structure. So the hair medulla is the core. Okay, so you can see this. The medulla is those little 4 cells there. It's soft. It makes your hair flexible. So your entire hair is made of keratin, but keratin can have many textures to it depending on how it's packed. So your nails are super hard, but they're also made of keratin. Your hair and your skin, your upper layer of your epidermis, is made of keratin, and they all have different textures, and it's all because that keratin is organized in different ways. So your inner gooey, soft part of your hair that makes it flexible is the medulla. Outside of the medulla, you have a cortex, which is harder keratin. It gives the hair the stiffness and the bulk. So you can see most of your hair in this layer here, right? So this pink layer in the center, that's the bulk of your hair, is the cortex. Then there's going to be a couple cell layers of cuticle. So it's very thin, but very, very tough. Again, hard keratin. And the cuticle is what you're going to put your hair products on, right? So to look shiny, you want to get the cuticle shiny. So that's your 3 layers of hair. So don't worry about the rest of this image. The other layers of the follicle is not important. I just want you to know how hair is, the anatomy of a hair. All right, so let's move on to our second structure associated with the hair, which is the sebaceous gland. The sebaceous gland is associated with every single hair, and it makes sebum. Sebum is your oil. Okay, it's the oil that accumulates on your hair and in your skin, on your skin. If you don't shower for a long time, you get greasy, and that's your sebum. Sebum is also the gland, or the sebaceous gland, I should say, is also the gland that can get infected with blackheads or with acne. So it is a source of acne, but it is also protective. You need sebum because this is lubrication for your skin. It's your natural lotion. Why do we need our skin to be lubricated? In our hair, because it becomes very, very brittle without it. And we've all maybe been in an environment where it's super dry, like we went to the desert. And if your hands are dry, they crack, and cracked skin will be more prone for infection or for damage in any way. So you want your skin to be lubricated with this sebum. So that's the sebaceous gland. So every single hair will have a sebaceous gland on it, and this is something that you want to recognize in a histology slide. Okay, I have in the outline that sebum is also acidic, slightly acidic, so that makes your skin slightly acidic, so it also inhibits microbes. The erector pili muscle is our third topic here, and this is a smooth muscle. It's smooth muscle. So you guys know what smooth muscle looks like in a histology slide, right? And it's associated again with every hair, and it's at this 45-degree angle to the hair. And when it contracts, it pulls the hair so it stands on end, and it gives you your goosebumps. Okay, so there's lots of hypotheses out there on why we get goosebumps. This probably relates to the fact that other animals like dogs and cats, when they get scared, they can puff up their fur to make them look a little bit larger. They think that maybe this is why when you get scared, you might get goosebumps, or if something's very emotionally, profound, you can get goosebumps. Another hypothesis is that when you have raised hairs on your body, it can actually conserve heat, creating a little bit of an air cushion in there, and that might be a residual sort of leftover muscle from our ancestors who had more of a profound ability to do that. Okay, so let's talk about, so every hair will have an erector pili muscle. Before we move on, I want you guys to look at these structures in a histology slide. So on the test, when you guys are looking at a hair slide, I want you guys to be able to recognize these things. I want you to be able to recognize the epidermis from the dermis. That's important. I also want you to be able to recognize the hypodermis. Now it's not labeled here, but I can see it. I can see where, I'm just going to draw like this, right? Hypodermis. Because all of a sudden, my connective tissue that's very dark in my dermis disappears, and I have a different kind of tissue, right? Remember, the hypodermis is adipose. So you're going to see a lot of white adipocytes, right? So here's it does point it out, subcutaneous adipose tissue. So that's the third thing I'm going to do third, right? It's a layer of the hypodermis. I also need you to recognize this erector pili muscle as well as the sebaceous gland, okay? Erector pili muscles are going to look like a thin pink line, and it's about a 45-degree angle from the hair follicle. So if the hair follicle is slanted in this kind of direction, then the erector pili is going to come off of it at like a 45-degree angle. Right, you're going to see something like that. I want you to also know the sebaceous glands. So sebaceous glands to me look like little clouds. So I can see that the number 5 is pointing to this area here, but I can also see sebaceous glands here. I can also see sebaceous glands here. Okay, so sebaceous glands are always going to be next to a hair, whether you can see them or not. It depends on the section you get, but they're going to be very close to the hair follicle. I also want you guys to recognize the hair follicle itself. So 5, 6, hair/hair follicle. Okay, so we can see the hair is on the inside where it looks hollow, but it's actually where the hair should be, and the entire structure is a hair follicle. I also want you to recognize the bulb of the hair. So 7, the hair bulb or the follicle bulbs, which is just the rounded end. And then I also want you to recognize the papilla. Okay. So the papilla is that pale connective tissue. It looks pale with our blood vessel network coming in to feed and nourish our hairs. So let's take a look at another slide of this. So this is a closer up image. We can see the epidermis here. We can see where the dark living cells are. So in this picture, this upper part here, this is the stratum corneum, where it looks like it's very light and ready to come off your skin. The darker, denser cluster of nuclei, this is going to be the rest of your epidermis. So this is going to be the stratum granulosum, the spinosum, the basal. Okay, so it's just the rest of the epidermis. Then after that point, we have all of this. This is the dermis. Okay. Now we see a hair follicle. HF is for hair follicle. The hair follicle, I can see the rounded bulb at the end. I see a pale center. That's my papilla. And off to the side, I'm going to look for a sebaceous gland, which is nice and labeled for me. So here is my sebaceous gland. Okay. And then I also see an erector pili. It's not labeled here, but it's right here. This is my erector pili muscle. I can see another erector pili, maybe you can too, over here. So the hair follicle that might be over here in the slide is cut off, but that's the erector pili for it. Okay, so don't worry about the other kinds of sweat glands. I won't ask you to identify those, but that's everything you want to know for something like this. Oh, and then also if I point to this structure here, what would we call that? That's our hair, but we can be more specific. That's our shaft, right? The hair shaft. Here's another image. All right, so this is a little bit zoomed out. So it's a broader view. Where's my epidermis, dermis, and hypodermis? My epidermis is very thin in this picture. Look, my marker is, right? That's my epidermis. Then my dermis is going to come all the way down where my pink ends. And then my hypodermis is going to be everywhere where I have this white adipocytes. So now I can start looking for other things. Some things are labeled, which is good, right? APM is the erector pili muscle, and then this is that little line. I see my hair follicle, right? That's my hair follicle. I see, at this level, I call this the hair root. And then I see the bulb, right? That's the bulb. And then I see that pale center, and that's my hair papilla. Okay. Sebaceous gland is nice and labeled as well. That's my sebaceous gland. I also see a little bit of gland here. I also see some gland there. All right. So I think that is it. Here's another one. This is blank. So this is something that you can use to study if you get an image like this, right? First, epidermis, dermis, hypodermis. Epidermis is nicely colored, this purplish maroon. Dermis has a new color, right? We're looking at blue. That's exciting. And then our hypodermis is white. Then we have our hair follicles. I can see 4 of them, right? So 1 hair follicle, 2 hair follicle, 3, 4. Sometimes you don't catch the whole hair follicle, but you can tell. Then every hair follicle will have sebaceous gland and erector pili. Sebaceous glands, erector pili, right here. Sebaceous glands. I don't see the erector pili. That's okay. It's present. It just didn't catch the erector pili. Same thing here. Here's some sebaceous gland, but I don't see the erector pili. I can see the bulb, right? The ends, the bulb. And in this one in particular, number 4, I can see the nice pale papilla. All right, let's move on. The yellow, just before we move on, the yellow that you see is going to be the hair itself. And so at this level, I call it the shaft. If it's lower, closer to the bulb, we call that the hair root. Okay? And that's about it for that slide. Okay, this is just for fun because people like to talk about hair. The curliness of your hair actually deals with the shape of the follicle. So if you have a completely circular hair follicle and it comes out nice and straight, you have straight hair. If you have a hair follicle that's a little bit off circle, your hair will be made not perfectly cylinder. It won't be a perfect cylinder. It'll have some wiggle to it, right? Some off center, off circular shape to it, which is going to be your wavy or kinky hair here. Curly hair, you can have all kinds of follicle shapes. So you can see the shapes of your hair, and also people have different thicknesses of each hair. So you can have thick hair, that means you have a large follicle. You can have thin, smaller follicles. You can have, this would be like a curly, thick-haired person. This would be a curly, thin-haired person. And then over your lifetime, what happens to hair is that the number of follicles you have that work start to slow down. So the number of follicles that function are going to become fewer. So their hair will thin. It'll just not every hair follicle is going to be churning out hair anymore. So your hair will thin, and then the follicles get thinner. The follicles will get smaller. So every hair that a person has is a little thinner as well. So not super fun things to think about, but everybody goes through it. So there it is. It's life. All right. So is that what we have for hair? Oh, the root hair plexus, number 4. I have to sort of scroll down to my last image here. So let's look at the root hair plexus. So I want you to look at the word root hair plexus is here. And this is a kind of nerve ending that is going to, you can see where it's pointing to, it's going to wrap around the bulb of your hair follicle, and it can detect the direction of hair movement. And it can basically tell you if someone's touching your hair, if there's wind blowing through your hair. So that's the root hair plexus. That's the base, nerve fibers at the base of your hair. Since we're here, let's take a look at this picture. I'm just looking at something right now. I didn't mention, I usually mention it in class. All right, so what we want to look at here is, again, epidermis, dermis, hypodermis. We have our upper papillary layer of the dermis, our reticular layer of the dermis. We have our hair follicles. We can see nice big sebaceous glands. We haven't talked about the other glands yet, but I want to talk about this guy. This onion-looking thing, this is a Pacinian corpuscle, otherwise known as a lamellated corpuscle. So this is the old word Pacinian corpuscle. But let's go and the textbook now that you have calls it the lamellated corpuscle. And this is a nerve ending that detects deeper pressure. So look at it. Look at it where it is. It is deep in the dermis, right? It's next to the hypodermis. So in order for this nerve ending to get stimulated, you have to push hard enough to go through all the layers of this guy and then stimulate that nerve in the middle. So it's kind of like an onion. So here's the nerve ending, and then it's wrapped and wrapped and wrapped with connective tissue, just like an onion. And so this kind of nerve ending you can only get to the middle by pushing down with enough force to go through all the layers of this onion, this connective tissue that stimulates the inner nerve there. So this is a nerve ending for deeper pressure. So deeper pressure. Whereas the other one, contrasting that to the other one, we talked about the, I want to say Meissner's corpuscle, but I think it was a Merkel cell. We talked about the Merkel cell. Merkel cells were way up at the top actually in the bottom layer of the epidermis. So I don't see it in this outline, but it would be way up here, right? The Merkel cells. And so they are way up in the skin, and they're going to get stimulated just by a little light touch. So 2 different kinds of touch receptors: light touch at the top of your skin, deeper pressure, the Pacinian corpuscle in the bottom of your dermis. All right, moving on to our last area here. Oh, I do have, so number 6 in your outline here, Pacinian corpuscle or lamellated corpuscle. That's what I'm talking about. Let's talk about nails and then some glands. So your nails, I don't spend a lot of time on nails, but the only things I want you to know is that, yes, nails are formed from keratin. And your stem cells, or the nail bed where your nails grow from, is called the lunula, right? And that's going to be, for a lot of people, it's a paler area at the base of your nail. So that's where your nails grow from. This organizes the nail. It's where it grows from. And I know this from experience because my husband had an accident where it was actually a table saw accident, pretty bad one, that went through his nail bed, his lunula. And so he actually had to get surgery because if you disrupt the lunula, the nail won't grow back smooth. It'll grow back lumpy, or it'll grow back awkward and off in different directions. And so that's kind of a bad thing. So anyhow, so your nails are keratin. All right, let's move on to our glands. So here are our exocrine glands. Remember, the term exocrine means that we're delivering our products outside the body or into a cavity, but in this case, we're going outside the body. And we already talked about the sebaceous gland, and we already talked about the sebum, right? That's the substance it makes. It is lubrication, and it's also antibacterial. Do you remember why it's antibacterial? Because it has a pH that's low, acid. Okay. Now, let's talk about sweat glands, the other kinds of sweat glands. They're watery solutions. They can flush the epidermal surface, or they can perform other functions. So the first one in your list is apocrine, this one here. This is going to be the fun one to talk about because this is going to be the one that gives you your body odor. So the secretions that it makes are viscous, meaning thick. They're complex, meaning that there's a lot of different kinds of molecules in it, organic molecules, and everybody's is different because we all know that everybody has their own special body odor. And some people are attracted to, a certain kind of body odor and not attracted to another kind of body odor. And this has actually been researched, and they have found that you're attracted to a person's body odor that has a very different immune system than you do. So you're kind of like looking for, or you're attracted to a mate that would have so your offspring would have a very diverse immune system, which is actually very healthy. Okay. Possible functions let's look at where they are. So your body odor glands, these apocrine glands, are found in your armpits, your groin, and your nipple region. So nice sort of pheromone, sexual areas. And so that lends to the idea that this may have been a pheromone. So it's a attractant. So your body odor is going to attract a mate. And so if you think about that, if you really wanted to find your true mate, you wouldn't want to put on any deodorant or any perfume before going on a date, right? You want to just have your own natural odors and see what happens. So the possible communication, so that's our pheromone. And it's strongly influenced by hormones. So during puberty, you might have a lot of stronger smell than later on in life. And the other thing about this gland is that it is sometimes yellow. So if your t-shirts get yellow armpits, it's probably this gland that is just secreting its substances and coloring your t-shirt. Let's talk about the other gland, merocrine, which is your sweat. So the sweat that cools your body off is the merocrine gland. This is mostly water, and also it can contain other, organic molecules in it. Salts, obviously, when you sweat, you have lots of salt building up on your water. This is controlled by the nervous system because your brain knows when you're hot, it'll trigger your sweat glands to produce more sweat. And very important thermoregulation. Okay, so I want you to look at one little detail between the two before we move on. Notice how your apocrine gland dumps into a hair, right? Look at this. The gland itself, which is here, moves that smelly substance into the hair. Why? Because the hair will get coated with it and then stand off your body, okay? And then that will carry your scent further away from your body. So it's a way of kind of moving that scent off your body into the wind around you. Again, if it's functioning like a pheromone, you want that to happen. Sweat, miracrine sweat that cools your body, does not have anything to do with the hair. It just will secrete its substances right onto the surface of your skin. So that should make sense because you want to coat the surface of your skin with water. All right, so let's take a look at this picture that we had here. Let's look at the two glands. We have our miracrine gland. Let's look for our miracrine gland, the gland that's going to go straight up. So this is a little gland here, but if I look a little carefully, I can see that it's going up, 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 up. Here it is to a sweat pore. Okay, so that I know is a miracrine sweat gland because it goes straight up to the skin to put water there. Miracrine sweat actually is also called apocrine. You see this word apocrine? That's the same thing. I do not see an apocrine gland on this picture, but the sebaceous gland is another gland that secretes into the hair follicle, into the hair. And the oil will coat the hair, and then the oil will then coat the skin from the hair follicle. Okay, so those are your glands so far. Our third gland, going back to my here, is our cerumenous gland, which is a modified apocrine gland, but it produces cerumen, which is earwax. Okay, and it's only found in your ear canal, and they think that earwax builds up in there because our ancestors slept on the ground, and there are all kinds of creepy crawly things that can enter all your different orifices, bite you. So your body protects your ears with a wax so that any critter that goes in there will get stuck in the wax. Mammary glands, I don't really talk about that much in this chapter, but mammary glands are a modified sweat gland as well, of course, to make milk. All right, I think we completed the skin. So I want you to take a look here. Notice this gland, it dumps into the hair. So this is an apocrine gland. Notice this gland goes straight up to the surface. So it's a apocrine sweat or miracrine sweat. Okay. So we have some questions to answer. Which of the following glands produces the type of sweat that's involved in cooling your body? The answer is letter C, miracrine. Which type of integumentary gland is involved in acne formation? Answer is C, sebaceous gland. All right, let's talk quickly about aging. So as I mentioned in the tissues lecture, when people age, every single cell in your body kind of ratchets down what it does. So repair mechanisms are not going to work as well. Regeneration is not going to work as well. So if we think about what's going on in skin, when you age, the melanocytes are going to reduce their job. So people will turn gray because the color of your hair is the melanin granules deposited in your hair. So if you're not making melanin, your hair is going to turn gray. You have fewer follicles. I talked about that, right? You have thinner hair. You have a reduced ability to repair because that's just what happens to the whole body. Decreased immunity because those cells that we talked about, Langerhans cells, they're reduced to about 50%. You have a thinner epidermis because the turnover of your epidermal cells will decrease. And because of this, you have a decreased vitamin D. You also have reduced sweat gland ability. So older people tend not to be able to thermoregulate very well. So they tend to overheat very easily, which is why when we have a heat wave, you have all these cooling centers, and sometimes you hear about older people passing away because they just can't sweat as efficiently as we do, or I shouldn't say we, as you guys do as you're younger. Your dermis gets thinner, and that's what leads to wrinkling. So for all of you out there who are concerned with aging and wrinkling skin, I don't understand why, but you're so young, but the beauty products are all targeted at dermis. Nobody cares about epidermis. Epidermis is, I guess, is for exfoliation, but in order for your skin to look plumper or to be less wrinkly, you have to regenerate the collagen and or plump up the connective tissue. So it's the dermis that actually causes the sagging and wrinkling. And then reduced blood supply, so reduced healing because blood is necessary for encouraging growth. You have a drier dermis because our sebaceous glands are not producing a lot of sebum. And then you change the fat distribution, right? So we talked about how older people have thinner faces and thinner hands. One kind of cool side by side, so I wanted you guys to see the actual histology slide of a young person. One of these is 19-year-old. One of these is a 60 or 74-year-old. And look at the dermis and look at the epidermis, right? Look, and these are from the same area of the body. So I'm going to have you just look at it and just guess. Which one do you think is the younger skin and which one do you think is the older skin? And I'll tell you the A, this is our 19-year-old. 19 years old, and this is a 74-year-old. Look at the thickness of the epidermis. We have a thicker one on the left-hand side in A. And then just look how much prominent collagen is here. The pink is really outstanding. There's a lot of thick pink areas. This one looks a little bit thinner, right? The pink collagen fibers are thinner and they're a little bit further apart and more scarce. So this is what young and older skin looks like in a histology slide. All right, last couple questions. Which of the following is a primary function of the integument? The answer is letter A, thermoregulation. Thick skin and thin skin refer to differences in. The answer is D, epidermis. Remember, the epidermis, it's the stratum corneum predominantly and the stratum lucidum. Okay, so both of those are part of the epidermis. Layer of skin that contains bundles of collagen, fibers, and elastin for strength. The answer is letter B, reticular layer of the dermis. All right, we're done with chapter 4.